Hello everyone, welcome back to the channel. This is Cis Theta Learning, and in previous video we understood one of the most important ideas in software engineering, that's abstraction. We saw how games like GTA hide massive complexity behind simple actions. Now today we are going one level deeper. We are going to study one of the most important network abstractions in distributed systems, that's RPC. And this video is going to get a bit longer. Please do have some patience, and if you don't understand in this, I'll have another video where I'll take a flow diagram and explain anything. So RPC, what is RPC? RPC is our remote procedure calls. So, and trust me, once you understand RPC, you'll start seeing it everywhere in the multiplayer game. So again, let's go back to GTA. So in GTA, right, imagine you're playing GTA, and if you press F, we know that we get into a car. Or maybe you want to buy some ammo, you want to start a heist, or you want to shoot another player, or you want to transfer money. So to the player, right, everything feels instant. But here's the interesting part: your game client usually cannot directly decide these actions. So I repeat, your game client usually cannot directly decide these actions. Otherwise, hackers would become literal gods, right? Imagine a hacker sending, I now own all the money in maybe Los Santos. So instead, your game client talks to what we say is a remote server, right? So it talks to remote server, and somehow that communication feels almost like a normal function call. That's an illusion, right? It's not a normal function call, because this is what exactly the RPC provides. So what's RPC? It's a remote procedure call, and the idea is beautifully simple. RPC allows a program to call a function on another machine. So RPC allows a program to call a function on another machine. So this is important. So it calls it on another machine as almost as if it was normal local function call. So let's say let's take an example of GTA again. Let's say you enter the vehicle, right? You enter that car, but in reality the function may actually execute on another process, on another server, maybe in another city, maybe even another continent, don't know. And yet the programmer writes the code almost like a local function code. So that simplicity is what that is a network abstraction. So so this is network abstraction, right? So that's network abstraction. And so now imagine you're building a multiplayer systems without RPC. Now for time being, let's say there is no RPC and you are building a multiplayer system. So developers would manually handle sockets, packet formats, serialization, then retries, acknowledgements, transport protocols, and many more things for every single interaction. That would be painful, right? Instead, RPC frameworks hide most of that complexity. So the developer simply writes, maybe in our case, buy ammunition, maybe go to a lobby, join lobby, send message, whatever it is. So while the RPC system handles networking underneath, which honestly feels a little like magic the first time you see it. So now let's again use GTA. Suppose the player presses F. So he presses F, then he enters the client. So when he presses F, he enters the vehicle, not client, sorry. Yeah, he enters the vehicle, and the player thinks, press F, enter client, simple, that's done. But internally, something much more complicated may happen. So let's say that's the client, and you have this enter vehicle and vehicle ID. There'll be many vehicles, right, when you're playing the game. Then there is this RPC system, then there is game server, then there is validation, response, and animation starts. And you'll also see in a game like GTA, right, you can stop anyone's car, but sometimes they move away from you. So you'll have to also check, is the car available, is another player already inside? If inside, what will you do? We throw them out. We know, right, what we do in the game. So is the player close enough? Is this cheating at and many more things. So we have cheat codes, but yeah, just in a generalization. So now how an RPC works? So RPC, so if we take these, right, So without validation, multiplayer games would become complete chaos, right? Actually, they already are sometimes, but yeah. But how does an RPC work? So now let's understand what happens internally during an RPC call. This is where things get really interesting. So an RPC system maybe has a client stub, RPC runtime, server stub, server logic. If it's too much, hold on. I'll have a proper flow diagram in the next video. So do watch that. So now so sounds complicated, but yeah, let's go step by step. Let's understand what is client stub first. So now suppose the client calls enter vehicle, right? So the client stub receives this. Now this is client stub, right? Now the client is I'm playing the game. So it calls this enter vehicle. So the client stub now receives the call. What client stub is? It's a code. I'll show it in the next diagram, next video's diagram. So for now, assume it's some code. Client stub is a code. So it receives this call. Now the stub has an important job. What that important job is? It converts the function parameters into a format that can travel across the network, because we are going to call something on another machine, right? So this stub has an important job to convert the function parameters into a format that can travel across the network. So this process is called marshaling. So a very important thing to remember, marshaling. So turning data into network friendly format. So why? Because networks don't understand functions, objects and classes, they only understand bytes. So after marshaling, the RPC runtime takes over, right? The runtime what all the runtime handles? It handles message transmission, retries, acknowledgements, encryption, network communication. So the developer doesn't manually manage the low-level networking, right? Again, abstraction. So again here you see this is abstraction, hiding complexity. So now let's come to the server side. Now what happens on the server side? Now see, the request has been sent and it has been converted into a format that can be transmitted. Now the messages reach the server runtime receives it and it passes to the server stub. So again, this is the code. What it is, we'll see in the left flow diagram in the next video, but it is also some sort of code. So the server stub now performs what is known as unmarshaling. Again, a very important terminology to remember. This is unmarshaling. So meaning it converts the network data back into usable parameters. So then finally, whatever we had sent, enter vehicle 101 is executed on the server. So the server performs, what all does it performs? Validation, logic, state updates, and then sends the response back through the same process. So this is important. And yeah, this is what I've written down. Now here's another important thing. Most traditional RPC calls, right, are synchronous, meaning when the client sends the request, it waits. The thread becomes blocked until response arrives. So yeah, so you send the request and it will be waiting till you get the response. This is what synchronous thing is. And once response is received, you continue the execution. This is why latency matters so much, right? In distributed systems, what matters? Latency. We'll see what it is. Latency. So even tiny delays become noticeable in games. So that's why multiplayer games work so hard to hide latency, right? So why? And one more thing is you cannot fully abstract, right? This failure. Though I've missed this LLY, you cannot fully abstract failure. Now here's something very important. RPC hides many networking details, but it cannot completely hide failures. For example, what if server crashes? What if the packet is lost? What if response never comes? What if timeout happens? So the system cannot magically guess what the application wants. So what should it do? So should it retry? Should it fail? Should it wait for some more time? Should it cancel the operation? What should it do? So it's all this is all on business logic, right? What you want to do, right? When a timeout happens, this is all business logic, and this is one of the biggest realities of distributed systems. So network failures are unavoidable. So when we come to real world, right, RPC is everywhere. So Google uses something known as gRPC, so for high performance communication between services. And Uber, right, it uses RPC for ride matching, location updates, real-time communication. And Facebook uses something known as Thrift to allow systems written in different languages to communicate with each other. So whenever large distributed systems need fast communication, right, RPC is important. So you can read about Thrift. Good documentation is available. So why RPC matters. So without RPC, right, developers would constantly deal with low-level networking details. RPC allows engineers to think in terms of maybe services, functions, interactions. So they do not have to instead waste their time on packets, maybe network packets, sockets, transfer protocol. So, and that abstraction is one of the reasons modern distributed systems are even manageable. So yeah, and honestly, once you start understanding RPC, you begin realizing that multiplayer games are basically massive distributed systems pretending to feel instant. So every action, maybe you shoot, or maybe you enter a vehicle, you buy some items, you do a matchmaking, whatever, may involve RPC communication happening behind the scenes. So in the next video, right, we'll continue exploring these distributed systems concepts, and I'll have this whatever I spoke about. I have to still explain what is client stub, what is server stub. So in the next video, I'll have a diagram where I'll explain what this is and how the flow is. So we'll keep the game aside in the next video. We'll purely understand technically how these steps are there. So, and if you enjoyed the video, do like, subscribe, and share with your friends. And if you know, please, if you need these written notes, do let me know. I'll share it. So see you in the next one. I hope you'll get a very good idea of RPC in the next video. Thanks for watching. Take care. Bye.